Look at your hair right now. Maybe it's straight, maybe it waves, maybe it coils so tightly it springs back when you pull it. You've probably never thought of it as anything other than the thing you deal with every morning. But here's what nobody tells you. The shape of your hair wasn't decided by chance. It was decided by sun, heat, migration, and thousands of years of survival in environments you've never seen. Your hair is not a style, it's a record. And to understand what it's recording, you have to go back to a problem your ancestors were trying to solve before civilization existed. The human body is strange compared to other primates. Chimpanzees, gorillas, our closest relatives, are covered in thick fur. We're not. Somewhere in our evolutionary past, we lost most of our body hair, and the leading explanation is heat. Our ancestors were moving through open, sun-exposed environments, walking, running, hunting, gathering for hours under intense sun, and the human body developed a cooling system unlike anything else in the animal kingdom: sweat. Millions of sweat glands releasing heat through the skin. But thick fur traps that heat. It blocks evaporation. So losing body hair may have made the cooling system dramatically more efficient. Except there was one place losing protection was genuinely dangerous: the head. Under your scalp is the brain, and the brain is the most expensive organ in your body. It uses roughly 20% of your energy. It generates heat, and it does not handle overheating well. Heat stroke doesn't just make you tired, it kills brain cells. For an early human walking for hours under a sun with no shade, no hat, no building to step into, the temperature of the skull was a survival problem. So the head needed a different solution. Not thick fur covering everything, but something that shaded the scalp, blocked direct solar radiation, and still allowed heat to escape. That something was hair, specifically shaped hair. Here's where it gets precise. Researchers at the Loughborough University ran thermal modeling experiments on human heads with different hair textures: straight, wavy, curly, and tightly coiled. The results were specific. Tightly coiled hair reduced solar heat gain on the scalp more effectively than any other type. The reason is structural. Tight curls and coils lift the hair away from the scalp. Instead of lying flat like a blanket, trapping heat directly against the skin, coiled hair creates a gap between the hair and the scalp. That gap acts like a buffer zone. The hair intercepts sunlight before it reaches the skin, but the scalp can still release heat upward through the space between the strands. In the intense sun of equatorial Africa, where our species first evolved, this difference wasn't cosmetic, it was functional. The shape of your hair on the top of your head could affect how much solar radiation reached your brain, a trait that reduced heat gain by even a small percentage, repeated over thousands of generations under relentless sun, could matter. That's how evolution works, small advantages compounding over time. But now comes the part that complicates everything. Humans didn't stay in equatorial Africa, they moved out of Africa, into the Middle East, into Europe, into Central Asia, into the Arctic, into the Americas, and they brought their hair with them. Then it changed. Straight hair is common across East Asian and Native American populations, and one particular gene variant, EDARV370A, appears at very high frequency in East Asian populations. This variant affects not just hair texture, but follicle shape, sweat gland density, and even breast tissue development. It's one genetic change with multiple effects across the body. Some researchers think EDARV370A spread because of cold environments. That thicker, straighter hair provided different thermal benefits in northern climates. Others think it spread partly through sexual selection, that the features it produced became preferred within specific populations. Some think it was genetic drift. A small founding population carried it, and it became common simply because those people survived and multiplied. The honest answer is probably all three, weighted differently in different places. Wavy hair shows up across Europe, the Middle East, South Asia. It may represent an intermediate adaptation, or it may represent multiple separate adaptations converging on a similar shape, or it may be the result of populations mixing, carrying straight and coiled variants into the same gene pool. Because humans were never isolated for long enough for hair to become a perfect climate map. We moved, we mixed, we split apart and came back together. The same region could have dozens of hair types because it was crossed by dozens of migrations. So when we ask why humans have different hair types, the answer sits at several levels at once: environment, migration, chance, sexual selection, genetic drift, biology interacting with history over thousands of years. Now go below the scalp. Hair grows from a follicle, a small living structure embedded in the skin. The shape of that follicle, the angle it sits at, and the way cells build the hair fiber as it grows all determine what the strand becomes. Round follicles tend to produce rounder fibers. Rounder fibers tend to grow straight. Oval or asymmetric follicles tend to produce fibers that grow unevenly, one side faster than the other, and that asymmetry creates curl. Think of a ribbon. Cut it evenly on both sides and it lies flat. Run your thumbnail down one side, stretching it slightly, and it curls. Hair works on a more complex version of that same principle. Uneven growth at the microscopic level creates macroscopic shape. But there is no single curly hair gene. Hair texture is controlled by dozens of genes affecting follicle shape, fiber diameter, growth angle, and the internal internal structure of the strand itself. That's why siblings can have different textures. That's why hair can change after puberty. That's why humidity, damage, and age can all shift what your hair does. The categories, straight, wavy, curly, coily, are useful shorthand. But biology doesn't respect neat boxes. A single head can carry different textures in different areas. The same person's hair can behave differently in different climates. And then there is the layer that biology cannot fully explain. Hair is cultural. Before modern salons, before recorded history, humans were already cutting, braiding, shaving, dyeing, and decorating hair. Across every culture ever studied, hair carries meaning. It signals age, status, group identity, mourning, celebration, religion, rebellion. In some cultures, cutting hair marks a transition. In others, covering it marks devotion. In others, the specific way it's worn identifies you as belonging to a particular people. For many people today, hair carries memory of family, of ancestry, of struggle. Natural hair movements in the 20th century weren't just aesthetic, they were political, a reclaiming of something that had been treated as wrong, as unprofessional, as less than, something that was always biologically precisely adapted. The biological story became a cultural story. What began as a thermal adaptation for early humans walking under equatorial sun became one of the most visible, most personal, most contested parts of human identity. Maybe that's why it feels so significant. Your hair is not random. It's not purely genetic. It's not purely environmental. It is the accumulated result of every environment your ancestors moved through, every population they joined or left, every survival problem the human body was asked to solve, growing out of your head every day, one strand at a time. Straight, wavy, curly, coiled? Different answers to the same question. How do you keep a brain alive under the sun?